DiDKey aims to harmonize regulation and blockchain through providing digital KYC in the digital age. It's a standard-based, decentralized ID verification solution that's blockchain agnostic on the sovereign network. So the concept behind DiDKey, in terms of what we do, we provide decentralized ID verification. We place digital privacy first. It's geared to the blockchain ecosystem. We embed regulatory transparency, secured by a distributed network, and DiDKey is the crypto solution for proof of identity. What we do in terms of business capabilities, we do digital custom onboarding, where we leverage facial recognition and we validate faces against a pillar of trust validation service. We do verification of identities, where we provide authorization to use or reference a claim, and we provide cryptography to actually validate the claim. We also provide secure sharing of identity data. We implement a standardized structure to represent identity claims that's interoperable across blockchains, and the user is in full control of what is shared. In terms of our core features, we convert a user's real identity into a digital self-sovereign identity. We selectively and securely share identifier data across blockchains. We verify the user identifier data through zero-proof knowledge proofs. We comply with the Financial Action Task Force fund travel rules while maintaining digital privacy and security. And we pseudo-anonymously demonstrate identity in other circumstances. And we prevent politically and privately motivated digital discrimination. So what are the challenges we address? Initial blockchain solutions created with anonymous identity. This results in opportunities that are bound for fraud and illegitimate activity. And as a result, it does not satisfy financial regulation such as KYC, so it is not widely accepted by governments and corporate institutions. Attempts to address identity on the blockchain are based on legacy analog PKI services or public key infrastructure services. These are based on a centralized certificate authority and issues certificates to everyone. However, certificate authorities have been known to be compromised and are susceptible to various cyber breaches that could weaken the entire identity ecosystem. In addition, data is shared insecurely with the owner of identity not aware of what is being shared. DiDKey addresses these challenges by providing an identity to the blockchain through a real natural person verification. It issues a set of identity claims that can be distributed across blockchains, and it allows identity data to be shared whilst maintaining privacy. So how we do it? We partner with government registries and legal identity credential issuers. We adopt emerging standards like the Decentralized Identifier or DID standard for widely acceptable use of identity and interoperability. We maintain privacy in the sense that the owner of the identity is always the holder of the private key and controls the identity claims that are shared. We leverage the sovereign blockchain network for providing a public permission blockchain for doing decentralized identity validation that allows for distribution both off and on-chain. We provide validation between blockchain nodes through zero-knowledge proofs, and we create a public-private pillar of trust for identity credentials. In terms of our solution, at the heart of our solution is the digital self-sovereign identity. This is an identity bridge that converts personal identity data into a decentralized identifier that's validated on the sovereign blockchain. Users, however, control the private keys to their DIDs and selectively share their data to when and how and to who. There's also blockchain ecosystem-wide IDs. Here, there are APIs that connect blockchains to sovereign, where self-sovereign identities are securely accessed, queried, shared, and verified, and they can be automatically verified DIDs and reference them in local off-chain transaction messages. There's also secure trust and verification. With identity data off-chain, but the validated decentralized identifiers on the chain, identity claims are verified with zero-knowledge proof at the consent of the private key holder without compromising any data integrity. Private transparency. On the front end, governmental and institutional registries attest personal identity data. On the back end, APIs include DID verification signatures in the transaction messages of linked blockchains. Regulators can then monitor verification in real time and audit decentralized identifier trades. So how do we do it? Okay, our solution comprises of process, technology components, and certain use cases. Okay, there is an issuance process where there are two key components, that of a pillar of trust, which issues the master bootstrap record to prove the nationality of the individual. There's key management that generates the secrets, and this is the private and public key base. Then there's the standards part of the process, where we actually use distributed decentralized identifiers. This actually allows for the data structure to represent an individual's self-sovereign identity in a standards-based, interoperable way. Then there's verifiable claims. These are attributes that can be verified with zero-proof knowledge. Then there's the participation leg of the process, where there is the distributed ledger, which essentially is blockchain nodes, and they are able to validate identity transactions to assure consistency. And ultimately, we have APIs, and these are actual interfaces that allow self-sovereign identities to be accessed, shared, and queried. In terms of the solution walkthrough, very simply, we would require a user agent. This is sort of a user with a device where he would basically have his identity created against some sort of off-chain profile store, be it a database, be it a customer relationship management system, or even an LDAP directory. Once his claim is created and verified, this will be posted into the DiDKey verification bridge service, which will convert the identity data into a specific claim. And this claim, depending on the type of claim, can be posted into the blockchain for a certain type of functionality. For example, we would have the identity verified and issue a KYC claim that can be posted onto the node and can be validated for banks or financial institutes. We can also issue a FATF claim, okay, which could be used for value-added service providers to validate sender and receiver of financial message transactions. In addition, this can also be extended to title deeds, where a title deed claim to attest the owner of the property through a valid identity can be posted to the blockchain node, and real estate providers can use to validate that. So this model essentially allows both an off-premise, off-chain model of where identity information is stored to be able to participate into a decentralized identifier system that's apparent in the blockchain. How we generate revenue? Our business model is predicated in terms of generating revenue from different types of fee generation mechanisms. So to participate in this entire node, we would charge a subscription. Once we validate an identity and issue the claim, we can therefore sell a claim and we can charge a fee for that. Then for people who want to query and look up an identity or validate the authenticity of an identity, we will make available a validation service API, and we will charge for consumption for each API call or a certain number of API calls per period. Then when transactions are done in the blockchain, and if a DID has been issued and posted by our bridge, we could charge a transaction fee as well. So who we are? Well, the core team behind DiDKey are three co-founders that are passionate about technology, passionate about digital innovation, and have an enthusiasm for accessing new challenges. So we have Eric Kennedy, we have Mohammed Zubair Umarji, and we have Marcus Angerman. Thank you. That is DiDKey, that aims to harmonize regulation and blockchain by providing KYC services in the digital age.